Using open source observability with Lambda. Well, let's start with where I am. So I'm Mike Elsmore. I am a developer advocate at Logz.io. If you wish to send me messages complaining or asking questions, you can get me at that email address or on Twitter at UKMadEls. I am more than happy to answer anything that is thrown my way. So what's the problem? Well, it's Lambda. Lambda is a problem in itself. It's a wonderful technology, and I have been happily using it in production since 2017, and it has kept me very, very busy over the years. But I am also a Node.js developer. Yes, please judge me for my JavaScript, but I like the fact that I can build things very, very quickly, and there is a module for everything. It's the JavaScript framework problem, but I think it's an advantage. In reality, this actually means when it comes to doing Lambdas, we are shipping whole bunches of them. So as was pointed out before by Jeremy, thank you for that. It makes my life a lot easier if I have to explain. If you have, say, I prefer using the serverless framework because of the way it bundles everything up and simplifies the process for you. It also just is quite happy and friendly and open source, which is, if you haven't noticed, I like open source. Yeah, so we ship, say, a service. This service can be 10 plus endpoints that could be used to make it up. So if we've got 20 services in a given region, each made of 10 plus, we then have to have it in 6 plus regions. We have gone from having a couple of hundred endpoints to keep an eye on to a few thousand endpoints to keep an eye on. And that just means the counter is going up. We've all seen the wonderful Netflix microservice diagram. And as far as I can tell, Lambda is the epitome of that diagram. It's how to look at something and just go, oh my God, I have to zoom out to planetary scale to be able to see it. But this time it's just Lambda everywhere. CloudFormation and Lambda in all the places to make all the things do the thing. So how do we actually work with this? Well, as a JavaScript developer and as most developers, we are used to just dumping out to terminal or standard out or standard error or a file. We are used to console.log and just working out what we're doing from there. And then we need to do something a little smarter, a little bit more transparent, so we actually can decide what is an error, what is not, and go from there. So next step is observability. And this, in my opinion, comes down to three, well, this is not my opinion, this is pretty much the fact of observability, is three primary components. First is logs. So we're all used to those. As before, I was saying, dumping out something and keeping them. Logs is just structured data that we can reuse. Then we have metrics. Now these are immutable objects and information for a specific compute unit. And then there are traces. Now traces, for those of you who are used to the monolithic world or just haven't come across the term before, it's like profiling. So it's an ability to see where the data is flowing A to B and any bottlenecks or anything that could occur in the middle. But I'll go into that in a moment. So a lot of people are probably going, not running that many Lambdas. I don't need this. Nothing's going to make it that hard. No, in reality, when you start shipping bunches of stuff like that and you're shipping daily new versions of the same Lambda or complete replacement services, or you switch from JavaScript to Python or blah, 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 everything can possibly go wrong because it's a hell of a lot of moving parts to keep an eye on. And it is nearly impossible for us as humans to keep a satisfactory and good eye on this. Yeah. So let's go through those steps, break them down, get into it a bit more. So event logs, ta-da! We're all used to these. Mutable data points. These are, timestamp pieces of information. These are used for debugging primarily. So we receive the information in plain text. So we're used to that with things like Apache log. Then structured data like JSON, XML, other, and binary. It's little used, but I've seen it with a few old WAR files or some larger streaming applications where it will use something like protobuf to dump out logs to an external point. Now, the best tools for using these to debug in the open source world are the ELK stack. So that's made up of Elasticsearch, which is the storage engine, Logz, which is the ETL tool, the means of breaking it down so that you can actually interpret it in Elasticsearch, and Kibana, which is the visualization tool that sits on top of the stack to allow you to investigate, probe, discover, graph, chart, etc. It's the bit that makes the data easier to perceive, because we can all stare at logs line after line after line trying to find where a problem is, but being able to see where there's spikes in information or changes in the pattern, it makes it an awful lot easier to find out what the problem is. And in recent years, there's also been, as well as Logz, beats. Now, beats for logging purposes, we have FileBeat, which is the one that essentially streams a file and interprets it as a log file. But there's also MetricBeat, Heartbeat, and there's a few others I can never remember off the top of my head. But these all serve separate jobs and stream the information into Elasticsearch. So MetricBeat is obviously going to be reading from whatever application or service, the metrics, and FileBeat the file. Pardon me. And so we will move on to metrics. Makes life easier. So metrics, the intermediate mode, the one that people usually ignore until they're trying to work out where things are going spiky in different locations. Why is the system working in one place and not in another? Once again, it's immutable data. There's no point with metrics when you're trying to see a real-time view of what your system is doing, how much the CPU is being consumed, how much memory, network, I/O, even disk usage, actual memory and disk usage. You need a fixed point in time, especially when you have hundreds of Lambdas using temporary storage to, say, do file processing in the form of image resizing or just image processing because you're trying to interpret PDF files to do something, just as an example. You need the immutable data because you could be suddenly spiking up and running out of memory and trying to work out why are all my Lambdas failing. You're trying to consume a 5 gig PDF and you've only allocated a gig of memory to said Lambda. That is a nightmare and not always the quickest thing to find when you are shipping to multiple locations. And you can also use custom information, so you can send custom metrics. Common use case is user behavior, so how a user is interacting with the system, and you then get to see the metrics play together. So say one user is sending a whole bunch of requests, but those are on small files, so small processes, whereas another user is sending 5 requests, but happens to be sending the mother load of SQL queries and making everything grind to a halt. You can use those metrics to identify where the problems are. And the best tools for this are, well, the most common now is actually, as far as I can tell, Prometheus, and Grafana is behind it. So both of these are, well, Prometheus is an entire stack upon itself, containing PromQL and the Prometheus interpretation engine. So you can store metric data, where they both can also run on Elasticsearch, which is the reason why we've played with them. And Grafana being the best one for that. So Grafana being able to run on top of Elasticsearch allows us to format information in a way that Grafana can interpret it for visualization, reporting, analytics. And that's what they're best for. These are the best tools in open source for doing so. There are a bunch of others like Graphite, etc., but these two are the strong forerunners. Tracing. Now, this is hard mode. This is the one that most people have seen the footnotes of blog posts or technical documentation, and most people haven't bothered to implement because why bother? Well, we should all bother. It's end-to-end flow of an application. This is seeing the data move from, say, the initial request all the way down to the data layer. and each trace is built up of spans. So you can, for example, inside of a large Lambda, you could have, say in JavaScript, you could have each one of the functions that's passed through interpreted as a span. So you can see which part of your code base is causing bottlenecks or slow runtimes. And this is brilliant within a microservice architecture, because by passing the context between different applications and different parts of the system, you're then able to interpret where there could be a possible bottleneck, where is an acceptable lag, where is something that is directly user interfacing that is having issue. And the best tools for this, there is actually a third one that I've missed off there, but I personally haven't used it, so I'm trying to avoid recommending it just in case somebody asks, are Jaeger and Zipkin. Jaeger is a project that was spun out of Uber. It currently seems to be the forerunner within the tracing world. And then there is Zipkin, which I believe is spun out of Expedia. They both do the same job in different ways, in the way they do sampling and interpret information, but they both, in general, follow the same process of giving you traces and spans and the ability to essentially debug and profile where there is a lag and issue in your system. And okay, keep forgetting I have to do this. Demo time, because there's no point in showing any of this stuff without actually interpreting it. So I have built a wonderful little Giphy implementation, which is grabbing the latest and greatest from Giphy and forwarding the information through to S3, which is then creating a single thumbnail of it. Hunky dory. So we've got API keys, all the usual things which we're used to seeing in CloudFormation. And there's also some helper stuff that we at Logz.io have put together to make this job a little easier. So inside of the ECS cluster we have stood up here, we have, I'm going to start with metrics rather than logs because it's the easiest one from this CloudFormation. We have this, which is our metrics collector. Now, this is actually just a Docker container that has metric beat pre-configured in there. And all we're doing is connecting that to CloudWatch to gather the metric information from CloudWatch, interpret it in a format that metric beat can format, and send that through to Elasticsearch that we can then interpret. And I will go show that now. So in the metrics, praying for stable internet whilst I'm in a vacation house, because I'm actually on vacation. Here we go. We have metrics, and as my event, as you probably saw in that CloudFormation file, my lambdas are on a 5-minute timer, just quickly grabbing stuff. So we can see it's throwing stuff. If we then go look at the Lambda specific, we're then able to very easily see the consumption for invocations and errors, the duration, runtime with this throttling, just very good overview. We can also add some more to this, but yeah, the default is enough to show off what we want to see here. And do I have any errors in here? I usually hope there's, I'm probably the only developer on the planet that's hoping for errors. Oh, excellent. Yes, we have an error. Well, we have one error in total since I turned this back on Sunday. Whoops. But yes, so here we go. We could then interpret this. We could drill down into it and see why there is spikes. I can also quickly have a look, change region, as you can do in CloudWatch, sorry, not Formation. To be able to do the same job, we can do it here. But I'm just going to have a quick look at this one, because this will be what I will show off next. So this is just the metrics helper that's there. This is the duration and runtime of our log shipper. So I'm now going to go back and look at our code base, if I have remembered to keep VS Code open. Excellent. And we can see we've got the hello function, which is just grabbing from AWS. So we've just got different log levels with logging at the info level. I'm also using a library in JavaScript called Winston. Winston allows us to interpret and send to multiple log locations, different levels of data. So in my case here, I am sending to the console, which is then being dumped out to CloudWatch for interpretation there, all statements from debug and above, whereas from our Winston direct connection to Logz.io, I'm sending only the info and above statements. So if you're not aware, from logs, you can declare different log levels of error, warning, info, debug, and I believe there's another one at the very bottom called either stupid or silly. I cannot remember which one it is. And you can use those to define how important the information is for you. For example, you obviously want to know about the errors and exceptions as well. And warnings you can probably live with. It's like, oh, warning, you're using quite a lot of memory, but things are still standing up, etc. So there we go. It's processing information. And then we have an S3 reader, which is just doing this essentially the exact same thing to produce more data for the purpose of Kibana. So go back to Kibana. And here we go. So now we can see that we have logs coming in, quite a few of them because I'm throwing in a lot of stuff, and we can interpret it. Now, with the Elastic Stack and Logz.io, we can then create alerting and further analysis and interpretation, or with Logz.io, we directly connect with a whole bunch of partners like PagerDuty, etc., so that you can do the rest of your ops flow from the back of this information. But here, let's have a look at our type. If we want to look at Lambda. Now, I do love the fact that with CloudWatch, the best way to get information on your Lambdas out of Lambda, if you're not directly sending information from the Lambda, is to create another Lambda and read from that Lambda to send to a third party. So you have Lambdas to read Lambdas that are sending Lambda data to something that isn't a Lambda. I absolutely bloody love that. And so here we can see that with our CloudWatch Lambda, this is the Logz.io helper that I had in the metrics that you quickly saw. This is sending over just some basic information. We are getting the ARN, the actual log information. Unfortunately, due to the way it processes the information from CloudWatch, it does interpret any JSON object as a string, which is always unfortunate. If we were to send the information in a string format and say run regex or grok on it from within Logz.io, would be wonderful. But because I was being lazy and using Winston to create a universal JavaScript object that's sending through, we kind of miss out on that. And so if I then get to look at, oh, now it's easier if I remove it from here. Bye-bye. Just look at the Node.js ones, and here we go. We now have the cleaner looking version, the ones that are sent directly from the application to Logz.io with the info level, access denied in this case. Ooh, an error. I obviously haven't typed that correctly to an error to actually make it interpret on the invocation end. Naughty me, developer. So yeah, here we go. We are able to break it down, and on there we could then create more complex Lucene-based queries to interrogate and interpret the information, which is quite handy. I wanted to just show what Jaeger and the traces actually look like from a usage perspective. So we've got the front end of one of our applications here. Just open it up, and here we go. We are able to go in and see this is the entire query from beginning to end, and the breakdown chart. It looks like when you're on a Chrome or a web browser and you open up the network tab and you're actually seeing how the effect of non-asynchronous calls are on each other. It's the same principle here, where we can actually look in and interpret the information and see how it's tagged up and how each part of the system, each span, is interacting with the next and causing any lags or delays. So that is a whirlwind and quick stop tour of observability. So that is going through the logs and how you can take them out of AWS and interpret them, how you can take the metrics out, and how you can get traces out. And I do like to push the open source, so I don't want to say it, but I kind of have to, because it's one of the big benefits is with using a tool like Logz.io and the rather than the open source, we are able to blend the information together to grab insights. For example, take your traces and interrogate the logs that are directly associated with it and metrics, etc. However, I personally feel that if you want to play with this, you should be playing with the open source. So can't do that directly, but you can very easily interrogate. CloudWatch is ridiculously powerful and holds a lot of information, but it was never and isn't designed for doing that very small, granular weird lookup stuff that a query language like Lucene or PromQL or Grafana does, or even Jaeger in the case of tracing. So you can get so much insight out of AWS's tooling in the way of CloudWatch and the associated X-ray, etc. But the moment you start using other tools, it can go further.
How does Logz.io address the need for scale?
That is a really hard question, because this is the need for scale is very much down to the workload and application you're building, as with everything in software. However, you always need to be able to customize and build on top of it. So Logz.io allows you to implement custom metrics, custom lookups, custom weird workflows that you may require. So yeah, in my opinion, as more of an engineer than an operator, the ability to just be able to quickly mock, build, and process those operations, queries, and runbooks is where the scale comes into it. Just being able to quickly build, share them is amazing.